day 1 of Unit 7, our unit on factoring. So the thing before we start this actual unit, I want to remind you our last unit was operations with polynomials. So we multiplied, added, all that good stuff. So factoring is actually the opposite of distributing. For example, when we distributed a monomial by a trinomial, okay, so we're going to go backwards in that sense. Also, when we did FOIL, okay, so for the most part, all of these factoring questions are going to be the opposite of FOILing. Okay, so first let's write our definition. Okay, so what factoring is it's the process of reversing multiplication. So again, the big thing, we did a lot of distributing, double distributing last chapter. So what we're doing now is we are doing the opposite of that. Okay, so pay attention to what your answers look like. Okay, so what your solutions look like. So what we're going to start with today, we want to answer the question, how do we factor using the greatest common factor method? Okay, remember that's just your GCF. So before we get started with that, let's write down what the GCF is. Okay, so the largest factor that two or more numbers and or variables have in common. Okay, so fill that in your note packet. Alright, so when we are doing these questions, remember of your factor trees, okay? So I'll show you two different ways that we can solve these. The first way, so if you think back, let's see, and I'll do, this one is a little bit shorter, so I'll do this one. So what you can do is you can write down all the factors and see which one is the greatest. So let me do that way first. Okay, so we have 1, let's see, so 1 goes with 10, and 2 goes with 5, right? So 1 times 10 and 2 times 5. So remember, factors, those are numbers that multiply together. Okay, and then I have 1 and 15, and then 3 and 5. Alright, so my GCF is 5. Alright, okay. The next way we can do this is we can think about when you make a factor tree. Okay, so let's say we had the number 8. We would do 2 and 4, and then 2 and 2. So it would be 2 times 2 times 2, right? That would be in simplest form. So 2 times 2 times 2. Okay, so now for 20, almost the same, but this is going to be 2 times 2 times 5. Okay, so since there are 2 2's that match up, okay, 2 times 2 equals 4. So my GCF equals 4. Now if you're just good at this, just looking at them, that's totally fine. You don't have to expand that every time, but just to kind of think of what you're doing there. Alright, so now with variables, this is very easy. Think about how you would get an x squared. Okay, so x squared is the same thing as x times x. And x is just itself. So the only thing that it has in common is one of the x's. So that means that you can pull out 1x. Okay? So remember that for where we're going. That's where we're going with this. Okay? So again, this would just be x times x times x times x times x. And then this would be x times x times x. So you see we have 1, 2, 3. So my GCF would be x cubed. Alright, let's do one more. Alright, so we got y times y. Okay, so just 7 of those. 6, 7, and this would be 2 times. Okay, so our GCF is y squared. All right, so let's make an observation. All right, what do you notice? What do you notice about this GCF? What do you notice about it? So what I'm hoping you notice, the GCF, and that's just, we're just talking about it with variables, okay? The GCF is the variable with the lowest exponent. Simple as that. Okay? Don't make it any harder than it has to be. Okay, so we are given, we want to find the GCF of 2a cubed b cubed and then 6a cubed b. So what we're going to do is we're going to break this apart. So we break it up into coefficients, into the a's, and then into the b's. So I have a 2 and a 6, so my GCF for that would be a 2. I have an a cubed and I have an a squared, so remember we take the smaller one, so the GCF would be a squared. And then I have a b squared and a b, so my GCF would be b. Okay? So then for our GCF, we're literally just going to multiply all these together or just write them like so. Okay? And that would be your GCF. I'll explain in a minute where we're going with this. All right, on to number 2. So I have 8xy and 6xz. All right, these are both even numbers. And actually the highest, the GCF would still be 2 for this one. I have an x and an x. Oh, this is a typo. All right. Sorry, guys. Okay, so the GCF of x and x, that would be x. And then the GCF of x and y, there's actually nothing. Okay, so see how, so I have an x and an x. I don't have anything else that's the same, so I can actually only take out a 2x. That would be my GCF. Okay. All right, and then the last one, so let's see if we can do this without rewriting the whole thing. Okay, so we have 20 and 30, so I hope you can see that our GCF would be 10. All right, now look at our x's. So I have an x squared and an x, so the lowest power is the x. And then actually there is no y in both, so you cannot take it out. So the GCF of number 3 is actually just 10x. All right, so now that we've reviewed that, I'm going to go over the whole purpose of that. Okay, so when we are factoring, again, this is just the reverse multiplication. Okay, so think of these answers. This is exactly what you would get. So the first thing we have to do is we have to figure out what the GCF is. Okay, what the GCF is. So we want to pull out the GCF, and we're going to open parentheses. So remember, we're making, so this is what our solutions looks like in the previous chapter. Now we have to get back to what they originally looked like. So we are going to be dividing essentially. Okay, so let's look at this and figure out what our GCF is. Okay, so I have a 2 and a 2, so of course we can take out a 2. Okay, I have an a squared and an a, so the highest one I can take out would be the lowest exponent, which is just an a, and then both of them have b's, so I can take out a b. So this is my GCF. So what I'm going to do is I'm going to divide everything by my GCF. Okay, so I'm going to divide this one by 2ab and this one by 2ab. Okay, so the way that this is going to look, all right, so let me cross some stuff out. Okay, so b and b cancel, an a with an a squared cancel, a 2 and a 2 cancel. Okay, so 2 and 2, a. Okay, so when these cancel, this equals a 1. Okay, please make sure you don't forget about that 1. That is a very common mistake. So the first thing you're going to write, okay, is that 2ab. Put that right out front. Okay, then you're going to open a parenthesis. We have 1a left, just 1a. Okay, and then we don't have anything left over here, so we put a plus 1. It's not a 0. Think of, so if you had 2 over 2, that's equal to 1, right? So 2ab over 2ab is the same thing. So my final answer is actually 2ab. Okay? So what we're going to put in here, all right, we're going to do the GCF. So the GCF goes on the outside, and then this is going to be the first term divided by the GCF, and then either plus or minus depending on what the actual question is. Okay, first term divided by the GCF. Okay. All right, so for your classwork, all right, it's only homework if you don't have time in class. All right, so for the homework, I'm actually going to do a couple with you at first, okay? So let's look at these two. I have a 3x and then I have a negative 3y. So the only thing I can take out is a 3. So my GCF is going to be a 3. Now to figure out what goes inside, I'm going to divide by 3. Okay, the 3's cancel, so I'm left with x minus y. Now remember, if you were to distribute again, you should be able to get back to what you started with. Okay, so let's look at this one. The only thing that is common would be the x. Okay, so we divide the x's out, so I'm left with c minus d. Okay, do one more. Right, so we have a 3 and a 6. M and n, those are not the same, so the GCF of 3 and 6 would be a 3. Okay, so if I divide everything by 3, I would be left with m, and then 6 divided by 3 is a 2, so 2n. Okay, so go ahead and finish those.